your mark, ready, set, let's go. Dance floor pro, I know, you know, I...
Welcome everybody. Today we're going to be discussing the properties of powers. The properties of powers are in place so that we know what to do when we perform operations on powers. So let's get right into it. The first example is what's called the product of powers. This happens if I'm multiplying two powers together. If they have the same base, I will multiply the exponent. It would look something like this. X to the second times x to the third becomes x to the fifth. I simply added the exponents. Another example is called the power of a product postulate. This occurs when I raise two numbers to the same power. So, for example, 3x all raised to the third power. This tells me I need to raise the 3 to the third power as well as the x to the third power. Altogether, I would get 27x cubed. How about if we divide? The quotient of powers theorem says that if I have the same base and I'm dividing my powers, I will then subtract the exponents. This would look a little something like this. If I had x to the seventh divided by x to the third, I would then subtract my exponents, 7 minus 3, and get x equals 4. Sticking with division, what would happen if I raised a fraction to a power? Well, each of the numbers, the numerator and the denominator, would get raised to the same power. So it could look something like this. If I had 2/3 raised to the third power, it would be 2 to the third divided by 3 to the third, and we know this would be 8 over 27. Now, what about those pesky zeros? Any number raised to the zero power will always be 1. So, even if I have 99 to the zero power, I still get 1. That makes it pretty easy for us. The last one is called the power of a power postulate. This happens if I raise one power to another power. I will multiply the exponents. So, for example, x to the third raised to the seventh power would equal x to the 21st because I multiplied 3 and 7. Alright, let's look at a few examples. When doing these examples, keep in mind these are the only properties that we'll use. There are some instances when multiple properties will have to be used in the same problem, but again, the properties don't change. So, let's look up top to the first example. I've got negative 18 raised to the zero power. Because it's raised to the zero power, my answer is 1. For the second one, I've got 2 to the third times 2 to the fifth. I have the same base, so I will add the exponents. 2 to the 8th power. I won't worry about simplifying right now. I'm strictly just looking at using the properties of powers. Alright, next problem. I've got 4 to the third power raised to the second power. Since I've got a power raised to another power, that's 4 to the 6th, because I have 3 times 2. Next, I have a power raised to a power, but I've also got this 4 sitting here, so remember, both pieces get raised to the third power. I've got 4 to the third equals, not equals, 4 to the third and w to the 6th equals 64 w to the 6th. There I had to combine and use two properties in the same problem. I do them one step after another. Okay, next problem. I'm going to be multiplying here. I've got 7 times 2 is 14, and I've got y times y to the 9th. I will be adding my exponents, and I get y to the 10th. I've got some division down here. I've got 8 to the 5th divided by 8 to the 3rd, which becomes 8 squared because I subtract my exponents. And for the next one, notice I have to take the 8th power to the numerator and the denominator. So this becomes m to the 8th over n to the 8th. Multiply that by n to the 8th over m to the 8th. Notice I'm going to have the same thing on the top and the bottom. So when this is all simplified, I get 1. All right, last question before I let you try some on your own. I've got x squared raised to the 8th power, so together that's x to the 16th. That's going to be multiplied by 2x to the 4th raised to the 3rd power. Well, 2 to the 3rd is 8. X to the 4th raised to the 3rd will be x to the 12th. When putting these together, I will multiply, and that means I'll be adding my exponents. So I have 8x to the 28th. Why don't you go ahead and pause and try the on your own problems and then check your answers. For the on your owns, you should have gotten 17 to the 7th, 5 to the 6th power, 10 to the 3rd, n to the 70th, 10 m to the 9th, and j to the 289th. If you didn't get one of those questions right, stop and try it again. If you're ready to move on, let's check out example number 2. In example number 2, we are asked to solve for x. Now, the way we can approach this is by looking at all of the bases being the same. Since all of the bases are 18, I will be adding my exponents together. In this case, that's 4 plus x. We know then that will equal an exponent of 12. Now I have a simple one-step equation that I can solve by subtracting 4 from both sides. So in this case, x equals 8. Now you give it a try. Pause the video and try the on your own question and check your answer. For this question, you should have set up the equation 2x plus 3 equals 7. And when you solve for x, you get x equals 2. If for some reason you did not get 2, try it again. And when you're ready to move on, let's check out the back. All right, on the back, we've got a couple application problems. As we scroll up to the top, we are going to look at writing some of these power problems in scientific notation. Remember, scientific notation is always with a base 10. So, if I have a number, for example, 2 times 10 to the 7th, this represents a 2 with 7 zeros behind it. We'll use this idea to figure out how many zeros are at the end of the number 5 to the 5th times 2 to the 5th times 32. Since both 5 and 2 are raised to the 5th power, I can group those together and say that n equals 5 times 2 to the 5th power, and of course times 32. Notice now that 5 times 2 is 10 to the 5th power times 32. So this tells me I have 32 with 5 zeros behind it, which answers my question. How many zeros are at the end of the number? In this case, that would be 5 zeros. All right, let's take a look at example number 4. In example number 4, we need to determine how many different ways you can complete a test if you leave no answer blank. On this particular test, it's 3 pages long, and each page has 5 questions. So 3 pages long times 5 questions on each page equals 15 total questions. Now, how many different ways can you complete the test if you leave no answer blank? Each question has C possible choices. So since there are C possible choices and there are 15 questions, there would be C to the 15 ways to answer that quiz. Pause the video and try the on your own question and then check your answer. For this particular quiz, it's 2 pages long and there are 6 questions each. That gives me a total of 12 questions on the quiz. How many ways can I complete the quiz if I leave no answer blank? Since there are C possible choices, there are C to the 12th ways to answer your quiz. Well, that's it. Hopefully you now understand the properties of powers. When you come into class, we'll practice more, and even, if you're lucky, get to try examples 5 and 6. Good luck, and I hope this was a powerful lesson.
I go psycho when my new joint hit. Just can't sit, gotta get jiggy with it. That's it, now honey, come ride. DKNY, all up in my eyes. You got a Prada bag with a lot of stuff in it. Give it to your friend, let's spin. Everybody.